Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see about 5 more common data science terms that are commonly asked in many data science interviews. Like people ask you these questions to know whether you understand these concepts better or not. Some of these topics are quite confusing, like even for people who have experience in data science. So make sure that you watch till the end of this video to ensure that you get a clear understanding of each of these topics. So let's directly get into the topic. The first one that we are going to see today is skewness and kurtosis. So skewness and kurtosis, both of these are commonly used in order to understand the distribution of the data set. So if I take skewness as an example, the data can be positively skewed, negatively skewed, or the skewness can be closer to zero. If the skewness is zero, it means that it is a perfect normal distribution, which means that the either side of the distribution is exactly same. In real world example, there will not be many scenarios. There might not be any scenarios actually which has a skewness equal to zero. There will not be any scenario where the distribution is a perfect normal distribution. It will be like a slightly away from zero. So that would be like in practical scenarios. So when we have data which is negatively skewed or positively skewed, let me show you with an example. So here, so this is an representation for a distribution which is negatively skewed, the top one, and then this one is an example for a data which is positively skewed. In case of negatively skewed data, what happens is the majority of the values are towards the point which is away from the minimum value. Majority of the points are towards the higher end. So as you see here, the median in case of a negatively skewed data is higher than the mean, which actually means that the majority of the values are towards the higher end. In case of the positively skewed data, it's quite opposite. What happens is the majority of the data is towards the lower end. So as you see here, the median in this case is actually lesser than the mean. So that's about like what is the positively skewed data and what is the negatively skewed data. It helps us to understand like how the distribution is. In many scenarios, for example, in case of linear regression algorithm, one of the basic assumption is a normal distribution. So when we have a data set which is not a normal distribution, not close enough to a normal distribution, we can think of any transformation like any transformation, data transformation that can help us to make the data, to bring the data into an normal distribution. So that's about the skewness. The next one is kurtosis. So kurtosis is also like to understand the distribution of the data. When we have a data which has a high kurtosis, it means that in a bell curve, it goes like the higher end is much more higher than a normal distribution. What it actually means is that there is possibility of many outliers. So when majority of the data are densely populated quite in the center, it means that there could be a lot of outliers which exist like quite away from the mean. In a real life scenario, when we have a data, it's important to understand the distribution of the data, and if the distribution is not quite matching with the requirement of the model, we need to ensure that we use suitable transformation in order to transform the data, and hence the distribution that meets the requirement of the algorithm that we are using. So that's about the skewness and kurtosis. So if you want to know more about skewness and kurtosis, I will provide a link to one of my articles where I have explained about like the differences. The second topic for today is scaling. So scaling is something that is commonly used in data science. We generally have multiple attributes when we work on a data science problem. Let's say we work on a predictive problem. For example, let's say we have an attribute called as an age, and then we have an attribute called as a salary. So age is generally like between, let's say, 0 to 100, whereas salary will be in hundreds of thousands. So these two attributes are like quite in a different scale, and quite the difference is quite massive. So what happens is when we use something like a gradient descent, or let's say we use a distance-based algorithm, like for example, k-means clustering, or k-nearest neighbor, or even support vector machine, which is distance based. In those scenarios, what happens is that these attributes which are of an higher scale tend to dominate over the values or over the attributes which are of lower scale. So in those scenarios, what is required is we need to ensure that we use a scaling in order to bring them into a similar state. Two common approaches that are commonly used are called as normalization as well as standardization. In case of normalization, what we try to do is we try to match the minimum value to 0 and maximum value to 1, and then we use the scaling method in order to redistribute the data between 0 and 1. So here this is what we do in the normalization method. In case of standardization, what we try to do is we try to bring the data, bring the distribution into something that is very close to a normal distribution. So that's the two different techniques that are commonly used in order to scale the attribute. So if someone is asking you about scaling, so you need to explain what scaling is, how it impacts a data science problem, and what are all the various techniques that can be used in order to solve the problem of scaling. The third topic or the third term for today is correlation. So correlation is an important topic. Many people assume causal and correlation are similar to each other, but they are not similar to each other. Correlation is completely different. What correlation means is, it means that two attributes are highly related, or the relationship between two attributes. That's what is measured using correlation. For example, let's say A and B are two attributes which are highly correlated with each other. So then it means that when A increases almost to a similar magnitude, B either increases or decreases. So the correlation can go either ways, like it can be highly positively correlated or highly negatively correlated. So depending upon the sign, it can go either ways. To explain this with a simple example, let's say we have two attributes, like the amount of ice creams sold on a particular day, as well as the amount of crime reported on a particular day. So in a particular data set, the amount of ice cream sold on a particular day as well as the amount of crime reported are highly correlated to each other, which means that if one of these attribute increases, the other attribute also increases. But what it doesn't mean is, it doesn't mean that the amount of ice creams sold on a particular day is actually increasing the number of crimes committed on a particular day. There is no causal, there is no interference between these two attributes. They are quite independent from each other. One value increases, the other value also increases, but the factor maybe behind both of them is the weather condition. So on a hot summer day, what happens is generally the crime rate increases, because like people will be generally pissed off on a hot summer day, and the number of people who consume ice cream also will be generally higher. So here the causal is the weather condition is actually the causal, like it is causing the amount of ice cream sold on a particular day to increase, as well as it is causing the number of crime on a particular day to increase. But there is no relationship between the ice creams sold as well as the crime rates committed. So you need to understand like what is causal as well as what is correlation. It is very important for you to understand that correlation is not causal. Correlation between two attributes doesn't mean that one attribute is causing the other attribute. When you work on data science problem, you will be seeing a lot of times values of attributes which are highly correlated to each other. So you need to analyze them to understand if one is causing the other or if both of them are simply highly correlated to each other. The fourth topic for today is confidence interval as well as confidence level. Again, many people, they try to confuse between these two terms. Some people might not have a clear understanding about what is confidence interval and what is confidence level. So let me explain with a simple example. So let's say we have an e-commerce company that wants to predict the number of items a particular person browses before making the final purchase. So this particular problem is quite huge. Let's say this particular e-commerce company has like millions of customers. There will be millions and millions of event data. It won't be possible for us to capture all those events data, like a click stream data, in order to analyze this particular problem. So in this particular scenario, what we usually do is we try to get a sample data and we try to compute this on the sample data. Let's say we take the clickstream data of about maybe 10,000 customers. So based on this particular sample, we try to identify like what is the average number of items viewed by the customers before making the final purchase. If the average range is let's say between like maybe 6 to 10, any particular customers view 6 to 10 items before making the final purchase. So this particular range here is the confidence interval. So we don't want to say like a particular customer will browse like 7 items before making the purchase, because like not all customers are same. It is actually a range of values. So what we do is, we based on the sample data, we come up with the confidence interval. We say like most of the customers are viewing 6 to 10 items before making the final purchase. So now in statistics, we always come with probability. We don't say a particular term without probability. So we always, whatever the claim that we make those claims with the probability. So what we do is, we say like 90% of the scenarios, the customers would view 6 to 10 different products before making the final purchase. So this 90% is the confidence level, is the amount of confidence that we have that the values will fall between these two values. So that's the confidence interval and the confidence level. So confidence interval is the range of the value, and confidence level is the amount of confidence that we have that the value would fall between these two values. In terms of like in 100 transaction, like how many transaction the values will fall between these two range. So that's about the fourth topic. The fifth one and the final one for today is homoscedasticity and heteroscedasticity. So these two terms are quite confusing, and many people maybe might not be aware of these. So homoscedasticity is one of the important assumptions in order to use the linear regression algorithm. So you need to understand whether all the attributes that you have follow the homoscedasticity rule. So what it means is, let's say we have an independent variable and we have a dependent variable, and the residual is when we use the independent variable to predict the dependent variable, the error is the residual. So no matter what the value we have for an independent variable, the distribution of the error is consistent. The error is like there is no pattern in the residual, or there is no pattern in the error. So to explain with a simple example, let's say we have property size and we have property value. So what we do is, we use the property size in order to predict the property value. If for any given size of a particular property, if the error that we are able to with which we are able to predict the property value is same, so then it means that it is like homoscedasticity. It satisfies the homoscedasticity condition. But what generally would happen is, as the property size increases, the property value will have a huge variance. There will be certain property which will be like extremely expensive, and there will be certain property which will be totally fine. Like let's say there are two properties with very similar size. One is very closer to the city, the other one is like in a regional area. So it means that the price of these two different properties are quite different. So what it means is, it means that this particular value, this particular attribute, the property value, doesn't follow the homoscedasticity. So which means that it is falling under the heteroscedasticity. So the error or the residual is not consistent across different values of like this particular attribute, which is the property size. So these are all the 5 different topics for today. I hope you would have learned something new in today's video. If you like what I am doing here, if you are learning something useful, please give a thumbs up and subscribe to my channel. And if you know someone who is interested in data science, please share this particular YouTube channel with your friend who is interested in data science, so we can grow our community as well. So that's it for today. See you in another video. Bye until then.